Today's lesson is part 1 on algebraic expressions. We're going to talk about the parts of an expression, how an expression is different from an equation, and we're going to write some expressions based on some information that we're given. Let's get started. So one big distinction we need to make first. What is the difference between an expression and an equation? Well, all equations have equal signs. So some examples of equations that you might see: 5 plus 8 is 13. X minus 15 equals 10. There's a longer equation here with some parentheses and things. This shows distributive property, actually. We'll learn that later in the year. And another equation here. They all have equal signs. Doesn't matter what other operation signs are in the problem, but they have equal signs. Expressions, on the other hand, do not have an equal sign. So they're going to look a lot like the problems I just showed you, with one exception. It just says 5 plus 8 now. It doesn't say 5 plus 8 is 13. So no equal sign. Same thing with the second one. No equal sign. No equal sign. No equal sign. No equal sign. So they are still problems that you can simplify. They have plus signs, minus signs, multiplication signs, division signs, parentheses. They just don't have equal signs. So there's another key concept here. Now that we know what an expression is, a problem without an equal sign, there's different types of expressions. Some expressions are numerical expressions, so others are algebraic expressions. So what's the difference? Numerical expressions are expressions like the one shown here. Something they all have in common: every part of that expression, other than the signs, are just numbers. Algebraic expressions, on the other hand, have a letter in here, and that letter, we're going to learn in a minute, is called a variable. So numerical expressions do not have variables. Algebraic expressions do have variables. All right, so now let's talk about the parts of an algebraic expression. This is going to be some terms that you need to know. You're going to be quizzed on these. They'll be in your homework, so it's good to understand the terms so that when you hear them in class or see them on an assignment of some kind, you know what you're talking about. So the entire thing, everything in the pink area here, is an algebraic expression. That whole problem together, when you talk about all of its parts combined, is an algebraic expression. The 12 times x here, the 12x, and one thing that you need to remember is that when you don't see a sign between a variable and a number that's in front of a variable, that means to multiply them together, so that would mean 12 times x. That yellow part right there, and this 8 part right here, so the two parts of the expression that are separated by the plus sign, are terms. So this algebraic expression has two terms. Again, terms are separated by plus or minus signs. Okay? The next part, the 12, this is a number that's attached to a variable, so the number that you multiply the variable by, so 12 times x. The 12 is connected to the variable, and the 12 is called a coefficient. The other part of this term, I've used this word several times already, the x, or any other letter that you want to use, is called a variable. There are certain letters that probably are not good to use, like O's and L's, because they look like numbers. But if you want to use, for example, the first letter of your first name, or any variable that does not look like a number, you can do that. All right? So the only thing that doesn't have a specific name is the 8 here, right? So we're going to talk about what that 8's called now. The 8, the number in blue, so it's just a number. So something that doesn't have a variable attached to it, it's just a number, it's part of an expression, is called a constant. And you may know from science class that a constant is something that doesn't change. 8's always going to have a value of 8. If I showed anybody in any grade level that number, they would have an idea of what the value of that is because it doesn't change. It's always 8. Okay, so those are the parts of an algebraic expression. So take a minute, hit pause. On your note sheet, you can identify the parts of the problem, the coefficients, the variables, the constants, and the terms, and then when you're done, unpause and see how you did. Okay, here are your answers, so take a minute to check. If you need to pause again, go ahead. Now let's move on. Okay, so translating words into math. So this is the other part of the lesson for today. Some expressions can be written both with numbers and symbols and in words. So let's start with some addition. Okay, If we want to translate addition, there are certain words you can use to mean addition. Most of the time you're going to say x plus 12 if you see this. So that is one mostly correct way to say it. We're not going to say x, we're going to use a phrase instead for a variable, but a number plus 12 is a correct way to say that. Okay, so here's some other words that you can use. What you'll notice is there's a vocabulary word sum that you probably have learned in elementary school, and other words that mean to add. So you could say, and it's color coded here so it's easy for you to follow, a number plus 12, or add 12 to a number, or the sum of a number and 12. It's not the sum of a number plus 12. The word sum means plus, so you don't say it a second time in the sentence. It's the sum of a number and 12, or 12 more than a number. So all those words in red mean to add. If you can see, everything that's blue in a sentence is the phrase a number. So when you see a variable, you're not going to say x or y or z or b or a. You're going to say the phrase a number. And then the burgundy 12 is just 12 in the sentence. Okay? So that's addition. Oh, there's one more. A number increased by 12. So to increase also means to add. Okay? Translating multiplication. There are several ways to say the expression here. So remember I mentioned earlier that if you don't see a symbol between a number and a variable, or a coefficient and a variable, that means to multiply them. So some words that mean multiplication. Okay, we're going to color code it again and say them. So we have a number times 17. That's probably how most people would say it, or 17 times a number. 17 multiplied by a number, or the product of 17 and a number. So again, we're using the word and to separate the two parts because product means to multiply. Okay? With multiplication and addition, you can switch the order. That's the commutative property, and the sentence and the expression will still mean the same thing. As you know, with dividing and subtracting, you can't switch them around. But if I said a number times 17 or 17 times a number, that will give you the same answer in the end. Okay? Now let's try division. Division, like I said, you can't switch around, but every phrase we're going to give you uses a translation that keeps the problem in the same order. And you'll see what I mean in a sec. So here, probably what most of you would say is a number divided by 24. But there's other ways to say it that are correct, and here's some different phrases you can use. Okay? So some ways to say it, we're color coding again. A number divided by 24 is what I just said. And keep in mind, remember, if you say 24 divided by a number, that would be incorrect because you're switching the order and you cannot do that with division. The quotient of a number and 24, or a number distributed equally among 24. And finally, a number put into groups of 24. So you can see that the blue and the burgundy in the problem are in the same order in every single one of these. Blue comes first, burgundy comes second. So with division, it's nice, the ones that you're learning this year, you don't have to worry about switching the order of the problem around at all. With subtraction, however, which we're going to get into in a second, you have to remember which ways you're allowed to say the problem when you translate. So translating subtraction, right? There's several ways to say this too. So here's your expression: a number minus 11. That's probably how most of us would just say it because minus is the most common way. However, there's plenty of ways to say this, and there's two categories. You'll see on the left we have minus, difference, and decreased by, and on the right we have take away, subtract, and less than. So it's going to get into the blue and burgundy again. The ones on the left are going to keep the blue and burgundy in the same order, and the ones on the right are going to switch the order. So you'll see as we go through. So some ways to say it. What I was just getting into, one group keeps the variable and constant in the same order, the other reverses. So let's get into this. Okay, so I'll show you on both sides. So these ones appear in the same order as the problem. And the ones on the right, as I mentioned earlier, will appear in the opposite order. So on the left side, we have a number minus 11, blue, burgundy, just like the problem on the top. We have the difference of a number and 11, so blue and burgundy. And then we have a number decreased by 11, again, blue and burgundy. Okay, on the right-hand side, when we say these. We're taking away 11 from a number. So whatever that number is, we're taking 11 away from it. So when we do that, the burgundy and blue get switched. You're taking 11 away from what you already have, which is blue, a number. We're subtracting 11 from what we already have, which is a number. So it switches the order. And this shows 11 less than what we already had, which is blue, a number. So you need to keep these straight because you're going to be quizzed on which ones keep the order the same and which ones reverse the order. So this little chart here, which is also in your notes that you have to fill out, shows you which ones go in which category, and you just need to practice to kind of remember. All right? So let's do some practice. Hit pause and take a minute. Questions 1, 3, 5, and 7 you're going to write as a phrase. Questions 2, 4, 6, and 8 you're going to write as an expression. And when you're done, you can unpause and see how you did. Okay, so here are some correct answers. I gave you guys a variety of ways to say the ones on the left-hand side. On the right-hand side, especially with questions number 2 and 6, make sure you have those written the correct way. Okay? Also with number 7 down here, make sure that you chose correctly with ones that you could use, depending on how you chose to say it. All right? So that's the lesson for today. We're going to get into more complex problems in the next lesson, but use the video to go back and rewatch or look at your notes as you go through and do homework and do some problems in class. I'll see you next time.